Hi everybody, Mr. Rubo here, and today we are going to talk about 2.8 a little bit more. So yeah, hopefully you watched my first video on 2.8. I went over inverses and went through um, how to find inverses, so we're going to do a little bit more practice with that, but we're actually going to do it with some rational functions, because this is the toughest of the bunch in terms of finding it algebraically. All right, so there's 6 steps here. Few of the steps we've kind of dealt with before, but there's a few that are specific to rational functions. So for the first step, switch x and y. Always do that. Then step 2, we're going to get the denominator out of the denominator. So we're going to multiply both sides by the denominator to eliminate the fractions. And then you move all the y's to one side and all the stuff that doesn't have a y to the other side. We say left and right, but technically it doesn't matter. Then you're factoring out the y. Okay, then you divide both sides by the terms remaining, and then rewrite the equation with the proper F inverse notation. All right, so let's do example just so you can see it kind of worked out here. And yeah, so first step, switch x and y. And remember, f of x is really y. So I'm going to, oops, that's a +3. Helps if you write the right things. All right, so what your first step is multiply, well, I guess second step, multiply by the denominator. Reason being, no longer have a fraction. We're going to distribute this out. So xy plus 3x equals y minus 2. So now I'm going to take the stuff with y's, move it all to one side. The stuff without y's, move it to the other. So I'm going to subtract y. And then I'm going to subtract 3x. So I get xy minus y equals negative 3x minus 2. All right. So now, and I'll just rewrite it up here, xy minus y equals negative 3x minus 2. Both terms on the left have a y. Now, we couldn't combine them because one has an x and one doesn't, but since they both have a y, I can do just a quick factoring, and I can factor out the y, and I'm left with x, and then I'm left with a minus 1. All right. Oh. And then remember, our goal is to get y by itself, so now I can just divide by x minus 1. That'll cancel, and I get y by itself, so I'm going to switch it to the f inverse, and what I have on this right side is my answer. And there you go. Okay. We'll do it again, just so you can kind of see another example. But it is that the hardest part is remembering like the idea to get the y's to the same side and then factoring out. All right, so let's go ahead, switch the x and y. So x equals 2y plus 1 over y minus 3. All right, multiply both sides by y minus 3. Distribute this out. So xy minus 3x equals 2y plus 1, because those canceled. Move the y's to the same side. So minus 2y minus 2y. And move the x's to the stuff without y's to the other side, which is this 3x. So I end up getting xy minus 2y equals 3x plus 1. Both have a y, so let's factor that out. And again, last step here, divide by x minus 2, because that'll get this by itself, which is exactly what we wanted. Oops, and we're no longer in f, we're in g. So it's g inverse is 3x plus 1 over x minus 2. All right, and there is how you find it with a rational function. All right, so now, as far as sketching the inverse goes, what we're really doing here, there's kind of 2 ways you could do this. One, you could draw in the y equals x line, which I will just do real quick. This guy is the reflection. Okay. So that's what we're reflecting over. But really what we're going to do is we're going to find some nice points. So I'm going to take like this point here. So this would be 2, 0. This point is really nice, 1, 1. This point right here is another good one, right? 3, 1. And then what we're going to do to draw the inverse is we're going to take these points and switch the x and y. It's the same as up above with the equation. It's just, we're just doing it with single points now. So 2, 0 is going to become 0, 2. 1, 1 is actually going to stay 1, 1. And then 3, 1 is going to become 1, 3. And then you connect it in the same fashion. So this was connected like this. Well, you just have to imagine this. You are connecting it with a U, but now this U, like this is still the vertex. Oh, my drawing was fairly bad. Oh, pretend that goes through. There we go. That was better. I missed that point slightly, but this would be the inverse of that function. Okay. Inverse is not a function in this case, but you could still draw the inverse. Okay. All right. So this one, same idea, right? I'm going to draw this in. Okay. Find some nice points. So 0, 0. I got 1, 0. Let's see. Let's find another point that's really nice. So 0, I'm sorry, negative 2, 0. I'm getting ahead of myself there. And really, that's about it. So let's reflect these. So 0, 0 is nice. It stays in the same spot. 1, 0, wow, that was really bad, becomes 0, 1. Okay. And then negative 3, 0 becomes 0. I'm sorry, that's a negative 2. Oof, there's a comma there. All right. And now the hardest part now is just, okay, figuring out how it connects. Well, you go to the negatives here in the x direction. Sorry, from 0 to 1, you go to the negative y's, which means from 0 to 1 here, you would go to the negative x's. So it would go like that. And then we're going to kind of follow this, and it doesn't have to be perfect. Do it as best as you can, and then goes like that, goes like that. And really, you could also see, like, this is why I drew this in, because you should have those points that are on that line still be on that line, even for the inverse. So there you go. There's that one's inverse. And again, very similar to the first one. It's not a function, but that's okay. It still has an inverse. All right. So this is kind of putting together what we did in 2.7 now, that inverse functions are inverses if and only if f of g of x equals x and g of f of x equals x. So to show that two functions are inverses, we must show that f of g of x equals g of f of x, which has to equal x. Okay. So yeah, what we're gonna do here is it's composition. We did this already, so it's nothing new. It's just now we actually know what our answer should be based on the fact that we have inverses. Okay, so just give me 2 seconds. I'm pulling up something. Okay, so it says let f of x and g of x be the functions below. Determine if they are inverses. So what we're going to do is we are switching. I'm sorry, we are substituting in f of g of x. Okay, so that means we take g of x and substitute it into f of x. So g of x is this guy, 1/2 x plus 3 halves, but then we're substituting that in for f, which means we're going to do 2 parentheses 1/2 x plus 3 halves minus 3. So you'll notice the x got replaced with g of x. So now I distribute and simplify. Well, that becomes 1x plus 3 minus 3, and that does indeed equal x, which is what we wanted. Okay, but we do have to check them both. It is 100% possible for it to work one way and not the other. So we have to do it the other way, which means we're going to do g of f of x, which means we're going to do g of 2x minus 3, because that is what f of x is. And then that means where we see an x, we're going to put 2x minus 3. And following order of operations, distribution gives us x minus 3 halves plus 3 halves. Those cancel, and you get just x. So that would mean that these are indeed inverses. Okay. All right. And then the last page here is basically sometimes we will restrict the domain of our original function to ensure that both functions are inverses, so that the original function and its inverse are both inverses. So here show that h of x and k of x below are inverses where x is greater than 0. So we have to show, our first step is that h of k of x has to equal x. Okay, so when we do this, we know k of x is this guy, so we know this is that, so we're going to say h of square root x minus 10, and we get square root x minus 10 squared plus 10, and hey, those two cancel, so you get x minus 10 plus 10, so we get x, which is what we want. All right, and then we're going to go ahead and do the other way. Now, I should have mentioned originally, so we k of h of x. This function right here only has a domain of x is greater than or equal to 10. So that's why we needed this restriction on both, because otherwise this function doesn't work. So yeah. So with this, we're going to go ahead and do this substitution. So k of h of x, so k of x squared plus 10. Well, you do square root of x squared plus 10, minus 10, right? Because that would be what was in for x. Well, you simplify what's on the inside, and you get x squared plus 10 minus 10. And then because we have a square and a square root, they do cancel each other out, and you're left with x. And there you go. So yeah. And yeah, there is, we know these are inverses. Okay. And then the last one here, again, this is the idea here. We say show that n of x and p of x below are inverses where x cannot equal 0 and x cannot equal 4. Well, domain of this one, x cannot equal 4. Domain of this one is x cannot equal 0. So again, they're kind of telling us that in the directions, but we're taking that into account just because it's technically not. If you don't take that into account, they're not exactly inverses of each other. All right, so n of p of x. So that means we're going to do n of p of x, which is 6 over x plus 4, which then means I'm going to do 6 over x plus 4 minus 4. Those cancel. So then you get 6 over x, which means you're really doing 6 times x over 6, right? It's that keep, change, flip. So keep the top, change it to multiplication, do the reciprocal of the bottom, and the 6's cancel, and you get an x. And then we do the other way, p of n of x. So it'd be p of 6 over x minus 4. And again, you get 6 over x minus 4 plus 4. Okay, it looks really ugly. But again, you follow your fraction rules here. You'd get 6 times x minus 4 over 6, right? You keep it, change to multiplication, do the reciprocal of the second. The 6's cancel. You get x minus 4 plus 4, which means you get x. And there you go. There you know that these two functions are indeed inverses. And that's how you show it, by doing the composition of the two into each other and seeing you get x. All right, thanks for watching, everybody. Have a good